Greetings, M Squared here, and today we're going to factor some trinomials, and this time the quadratic coefficient, that is the number that sits in front of x squared, is not going to be 1. So a is going to be bigger than 1. So remember, a is the number that sits in front of x squared. It's called a coefficient when it's multiplied by a variable. B is the linear coefficient, the one in front of the x, and c is our constant. So we're going to factor things like this today. But we always have to remember that our greatest common factor is the first step in factoring. Always look to see if it has a greatest common factor. And if it does, you must factor it out first. And then we are going to ask ourselves, every time we factor something, we're going to say, what factors of AC, that's this number multiplied by this number, including the signs in front of them, add up to B, and that's going to help us factor. So B is that number right there. Even if these are switched around, A always is the 1 in front of x squared, B is always the 1 in front of x. If there's no x, then B is 0. If there's no C, then C is 0. There will always be an A in a quadratic trinomial, otherwise you can't have a quadratic. Okay, so the first thing we're going to do is ask ourselves, is there a greatest common factor? No, 3, 5, and 8. 3 and 5 don't have anything in common. There's no x over here, so we're good. So we're going to actually multiply A and C. If you don't know what A and B and C are, then we probably want to write that down. So A, B, and C, including the sign in front of it, so that's a negative 8. So we're going to multiply A times C, we get a negative 24, and B is 5. So we are looking for factors of negative 24 that add up to 5. That's what we're asking ourselves. So what you could do is just start writing them. This is kind of what I do. And I think about it. Hey, if I'm going to multiply and get a negative 24 and add and get a 5, that means one of the factors had to be negative and one was positive. If the sum is positive, then I know my smallest factor is going to be negative. So I'll start with the smallest. I always put the smallest factor on the left. It doesn't matter, but that's what I do because I like to do it systematically. Well, 1 and 24 gets me 23. Definitely not that. So I go to 2 and 12. 2 and 12 gets me 10. Getting closer, but not quite. So I go to 3. 3 goes into there 8 times, and there I go. 8 minus 3 is 5, so I know these are my factors. So then what we do down here, remember, is we always put our ax squared here and our c here. We're going to use the box method. There's other methods. You can look it up on YouTube. There's tons of different methods. We're going to use the box method in our examples. So why we did this was we're going to put the 3x from that 3 and the 8x from these two factors in those two boxes. And then we're going to use distributive property to find out what the binomials are that are going to multiply together to get my 3x squared plus 5x minus 8. So what I do is in the column I pick out the greatest common factor down this way and put it there. I pick out the greatest common factor in this column and put it above it. And then I do the same thing on the rows. The greatest common factor is x. And if there's two negatives, I always pull out a negative. And what's the greatest common factor there? Oh, that looks funny. Did I mess up somewhere? There is no greatest common factor there, so that would be a 1. Okay, a negative 1 though. Okay, so let's see if it works. So, does x times 3x equal 3x squared? Yes. Does x times 8 equal 8x? Yes. Does negative 1 times 3x get me a negative 3x? Mm-hmm. Does negative 1 times 8 get me a negative 8? Okay, that's my check. If that's true, then these are my factors, and I just write them down. Presto, and we're done. And we already checked. Now, if you didn't check in the box, you could always check using FOIL, right? We'd get 3x squared plus 8x minus 3x minus 8. And these two combine to get my 5x. So there's two different ways to check. If you're making the box already, you might as well just check in the box. If you're avoiding the box because you just can see it, then make sure you check using FOIL. Okay, so what's our first step? Always find the greatest common factor. Here, look, they're all divisible by 5. So we're going to actually factor out a 5 first. So if I divide that by 5, I get, remember, this is what we're doing when we're factoring out the greatest common factor. We get an x squared. If I divide 80 by 5, I get 16, not 80. And if I divide 315 by 5, you can get your calculator out. I believe that's 63. And this is a 16. 16. Okay, so now I have to ask myself, this is my A. My A is 1, my B is negative 16, and my C is 63. When we factor out the greatest common factor, we're just using this part to find out the two binomials. We need to, at the end, put our little 5 back in front, but we don't want to use it when we're factoring out when we're factoring this trinomial, this quadratic trinomial, because it just makes it easier to not have such big numbers. Because we need to find A times C. A times C is 63. And we need it to add up to 16. So what we're going to do is we're going to come over here and we're going to notice that I'm multiplying to get a positive. I'm adding to get a negative. That means they both have to be negative. Now some people can just see the factors in their head, but if you don't, you're just going to know that they're both going to be negative. So we have negative 1 and negative 63. Then we have, remember 63, if you can see the factors, that's 9 times 7. And what do we know about 9 plus 7? Do you see it? If you don't see it, though, you can just keep going. How many times does 3 go into there? I think 3 goes into there 21 times, and then you can keep going. But I see the 9 and 7. Once you see it, then you can just stop and know that those are factors that you're going to use for your little box. Okay, so remember x squared goes there. 63 goes here. I don't know if you remember from the last lesson we did, but if this is if A is a 1, if there's no number in front of the x squared, then really those are your two. I mean, we can take out the greatest common factor, right? It's, let's see, negative 7 there, negative 9 here, because that way we get our positive 63. We pull out an x. Anyway, we remember from last time that when the A is 1, that we really just, the two factors are just what goes in the parentheses. But you could have always pulled it out there. And then double check, right? We can check x times x is x squared. X times negative 7 gets me my negative 7x. 9 times negative 9 times the negative 7 gets me my 63. And x times negative 9 gets me my negative 9x. Just make sure you put that greatest common factor out front. Okay, just a few more. So check for a greatest common factor. There is not one. So A is 6, B is 7, and C is 2. So AC, right, is 12, and B is 7. So some people just think, oh, 3 times 4 is 12, 3 plus 4 is 7. And that's good. Remember, if you want to, you can do this all out. But if you just see it, then we're going to put our 3y and our 4y right there. And we'll put our ax squared here, or in this case it's y squared, and our c there. Always do that. So, greatest common factor is 2. Greatest common factor is 3y. Greatest common factor is 2y. And greatest common factor is 1. And then, when I make my binomials, because remember, factoring means a trinomial, I'm finding two binomials that multiply together to get me back there. I can check it. 6y squared, 3y, 4y, and 2. So I'm good. I'm going to say 2y plus 1 and 3y plus 2. So those are the factors. Okay, let's try this one. No greatest common factor. 9 doesn't go into 49, and 3 doesn't go into 49. So what's A? It's 9. What's B? There's no x. That means B is 0. So I'm trying to get two factors that add up to 0. And C is 49. So what is 9 times 49? Now this is where, if you need to, you can use your little calculator. So 9 times 49, I'm going to use a calculator on this one. Yep. Okay, so we've got 441 as our, whoops. Oh boy. Okay, let me get rid of that so you can kind of see it. Okay, now it looks better. 1. That's our AC, and then our B is 0. Oh, I forgot my negative. It would have been a negative 441 because that would have been a negative 49 times a positive 9. Okay, so what are the factors? Well, I know 3 goes into it because 9 does, right? This is 9 times 49. That doesn't get me a 0. And if I ever have to have a 0 or a really small number, I know that I'm going to have numbers that are closer together. In fact, in this one, they have to be the exact same except opposite signs. So I probably wouldn't start with 3 and whatever 49 times 3 is, 147, because that's just not going to work, right? Okay, so I might start with 9, and what's 9? 9 goes into there 49 times. Oh, I should have known that. Okay, so now I'm going to go to the next one. 7 would have worked, but what about 3 times 7? 21. So I'm going to say 441 divided by 21, and what do you know? It's 21. So there they are, because if one's positive and one's negative, which is what you need here, then those are my factors that add up to 0. So I'm going to put a 9x squared here. I'm going to put a negative 49 here. Then I'm going to go 21, negative 21x, and a positive 21x. So those are my factors, 21 and 21, that add up to 0. So then I take out my greatest common factor to figure out what goes in these parentheses. So here, it's a negative 7 that goes into both of those. Here, it's a 3x. And here, it's a 3x. And here, it's a negative 7. So we double check. Negative times a negative is a positive. That gets me, let me see, I don't want that to be negative. See, I checked it. I was wrong there. I shouldn't have taken that out, the negative, because I need this to be a positive. So I need that to be a positive. And then this, and I'm checking, and so everything looks good. So 3x plus 7 and 3x minus 7. That's why you check, because it's easy to make a mistake. And it's easier to fix it there than it is when you come over here, in my opinion. All right. First step in factoring is greatest common factor. What is it? Looks like it's 4. Okay, so we're going to divide that by 4. What do we get? We get 4m squared. 4 goes into there 1 time with, let's see, 3 left over. Goes into there 9 times. 36. So that's a 19m, and then we have a plus 21. So remember, we're going to have a 4 over here with our binomials. That's our greatest common factor, but for our box, we're just going to factor this. So I put my AC here, and I put my AX squared or M squared here, and then I put my C here. And then I'm going to find 2 factors of AC that add up to 19. Well, what is AC? Let's see. Remember, we're just using this. So our A is 4, our B is negative 19, and our C is 21. So it's just 4 times 21. So that gives me an 84. And I want to get a 19. So I'm going to start, they kind of have to be a little bit farther apart. So instead of starting with 1 and then 2, this looks like it's going to have a lot of factors. I'm going to start with 4 and 21. And what is 4 minus 21? So here's where calculator can come in handy. Let's see. 21 minus, 4 minus 21. If you just do everything in your calculator, I'm getting a negative 17. Okay, so I need to keep going. Does 5 go into 84? No. Does 6 go into 84? Yes. Okay, so 84 divided by 6 is 14. But one of them has to be negative. So I'm going to subtract there, and what do I get? 8, I believe. And then, okay, does 7 go in? Yes, 7 goes in. How many times? I believe 12 times. So I'm going to have a negative 12. What's 7 minus 12? It's, we're going the wrong way. We need a 19. Oh, my. Oh, wait a minute. We are supposed to have 2 negatives, aren't we? My apologies. I need a positive 84 and a negative 19. So this does actually work, because I was thinking, wait a minute, we're not going to get a 19. If that happens to you, that's a common thing, right? You're saying, hey, wait, I don't get a negative 19 anywhere. And then I realized, oh, maybe we should add them because we need to have them multiply together to get a positive. So that means 2 negatives. So there's my negative 19. So that should have been added. That would have been a negative 20 and a negative 25. Let's make our corrections. Oops, yes, I make mistakes too. Mistakes are okay. Finding the mistake is the challenge. Okay, so I put a negative 7m and a negative 12m. And let's find the greatest common factor. I'm going to pull it out here because I kind of made a mess there. So greatest common factor here is in a negative 7. And here is a 4m. And then up here would be a 3, and I think a negative 3. We have to get a negative times a negative to equal a positive. And then here would be an m. So let's see if that works. Does 4 times m equal 4m squared? Yes. Does this get me a negative 12m? Yes. Does this get me a positive 21? Yep. And do these two get me a negative 7m? Okay, I'm good. So I'm going to say m minus 3 and 4m minus 7, including that 4 out front that we took out from the greatest common factor. All right, last example we are going to do. So greatest common factor, no, there's not a greatest common factor. So our a times c is negative 300 and our b is negative 20. So we're going to have one of each factor because this is negative. So sometimes, especially when I do 100, when I have 100, anything 300, 500, I just say, what's 3? I do 3 times 100, or I do 30 times 10. And I check those first because they're really easy to check. And I don't know if you've noticed it, but negative 30 times 10 does get me negative 300. And what do I get when I add them? I get a negative 20. So sometimes I just like to pick the obvious factors and check them real quick. And that's easier than saying 3 times 100 and 4 and 5 and 6, because this has a lot of factors. So I found it. Negative 30 and 10. And I put a 3x squared here and a negative 100 here, and I factor it out. This factors out. That's a negative 10. This common factor is just an x. This common factor is a 3x. And this common factor is a 10. So let's double check. 3x squared, 10x, negative 100, negative 30x. Okay, that's our check, so we're ready to go. We've got an x minus 10 and a 3x plus 10. And that is our answer. So that's the box method. Like I said, there's lots of methods. There's a magic x method. There's just a check, guess and check method, which is really what I use most of the time. But it's up to you. Since we just finished multiplying using our boxes, I figured it'd be an easy one to do. So good luck with that. M squared signing out.